All right. So it says, consider the reaction between hydrogen and chlorine gases. You guys, what's the formula for hydrogen gas? H2. Remember, it's one of those diatomic gases. Do you guys remember me telling you about Brinkelhoff? Yes. Last week we talked about Brinkelhoff, last Tuesday. The elements that are the diatomic elements, Brinkelhoff, the Br is bromine. The I in Brinkelhoff is the iodine. The N in Brinkelhoff, that's nitrogen. Then it's Cl, that's chlorine. And then H in Brinkelhoff, that's hydrogen. And then O, that's oxygen. And the F in Brinkelhoff, that's the fluorine. Those are your 7 naturally occurring diatomic elements. Okay? So, hydrogen and chlorine gases react. What's the formula for chlorine? Cl what? Cl2. In Brinkelhoff, the Cl, the Cl, is chlorine, Cl2. It's also diatomic. So H2 plus Cl2 produces hydrochloric acid, hydrogen chloride, HCl. Okay? Is that equation balanced? H2 plus Cl2 yields HCl. No. How am I going to balance it? Put a 2 where? In front of the HCl. You got it. So we're going to put a 2 in front of the HCl. Okay? Next, it says how many liters of hydrochloric acid, so that's the HCl, how many liters of hydrochloric acid will be produced by the reaction of 2.0 liters of chlorine with an excess of hydrogen. In other words, we've got as much hydrogen as we need, like an unlimited supply, but we've only got 2.0 liters of the chlorine, and then we run out. When we run out of one of the reactants, the reaction stops. Okay? So, you guys, we're trying to go from liters of one substance to liters of another substance. Okay? All right, so, say that again. I do have a Band-Aid. Okay, so we need to go from liters of one substance to liters of another substance. All right, so you guys, we could do this problem the long way. Are y'all listening? Yes. The long way would be to convert liters of chlorine into moles, and then moles of chlorine into moles of HCl, and then moles of HCl into liters of HCl. In other words, this could be a 3-step problem, just like mass-to-mass stoichiometry. Are you guys following? So I'm going to set it up that way. I'm going to show it to you that way, and then I want to show you something that happens. So if I write 2.0 liters of chlorine, you guys, how do I convert liters of chlorine into moles of chlorine?
You put another liter thing.
Okay. What's the number? What is the standard molar volume? 1 mole equals what? Okay, so 1 mole of chlorine equals 22.4 liters of chlorine. To get the liters of chlorine to cancel out, so we use our standard molar volume. 1 mole equals 22.4 liters. Okay, and then we go from moles of one substance to moles of another substance. And to go from moles of one substance to moles of another substance, what do we use? What have we been saying up here? To go from moles of one thing to moles of another. What do we use? Coefficients. We use our coefficients from the balanced chemical equation. So our coefficients this time would be 2 moles of HCl for how many moles of chlorine? What's the coefficient in front of the chlorine? For every 1 mole of chlorine. You got it?
How do you know which one goes on the top, which one goes on the bottom?
In order to get the units to cancel, the moles of chlorine has to go on the bottom and the moles of HCl has to go on the top. So I'm arranging it. That's why I said putting those units into these problems really helps you figure out whether to multiply or divide. Okay? It really does tell you this is the only way to set it up to get the units to cancel. All right? Now, if I want to go from moles of HCl to liters, how do we convert moles of a substance into liters? What do we use? What have we been using all morning? 22.4. 1 mole of HCl has what volume? 22.4 liters of HCl. And that gets moles of HCl to cancel.
This is not that easy.
Well, let me show you something, though. Here's what I'm trying to get at. If we look at this problem, because the way that we've set it up, this is just like mass-to-mass stoichiometry. It's a 3-step problem, okay? But in this particular problem, what you're going to notice is that the standard molar volume, unlike molar mass, is the same for every substance. Molar mass of a substance is not the same. But look at your standard molar volume that's in the numerator and in the denominator. What do you notice about those numbers? The 22.4 is the same. So you've got one of the 22.4s on the top and one of the 22.4s on the bottom. So what happens is the 22.4 cancels out. So all that really matters in this problem, you guys, is that mole-to-mole ratio. That's all that matters. So this problem actually greatly simplifies. It just becomes 2.0 times 2 divided by 1. And what's 2 times 2? 4. Good. All right, so 2 times 2 is 4. How many significant figures were in the number 2.0? 2. So how am I going to write 4 with 2 significant figures? 4.0, and my units are going to be liters of HCl. Okay? Okay. So now, okay, what was your question?
Oh, Pacific Atlantic.
Uh-huh.
I was trying to remember what was that thing that you said.
What? Yes, the Atlantic Pacific rule. This one is a Pacific because we've got a decimal is present. Okay? So if a decimal is present, we start with the first non-zero digit on the left-hand side, the Pacific side, and we count all the way to the right. Okay? All right. Now, I want to show you guys something. Okay? I'm going to erase everything that we just did. Okay? I'm going to put our equation back up there. Our equation was H2 plus Cl2. You guys, we're almost done. Hang in there. Okay? Hang with me just a little bit longer, please. Okay? So H2 plus Cl2 yields 2HCl. And the question was, if we start with 2.0 liters of chlorine, how many liters of HCl? So you guys saw in that last problem that the 22.4s canceled out. Do you guys remember that? So in other words, we don't really need to go through that whole 22.4. In other words, you guys, it is okay to convert directly from liters to liters using a mole-to-mole ratio. And where did we say that those mole-to-mole ratios come from? Where do we get the mole-to-mole ratios from? The coefficients. The coefficients in, and I keep abbreviating here, the BCE, the balanced chemical equation. But instead of writing the mole-to-mole ratio as, for example, 2 moles of HCl for every 1 mole of chlorine, instead of writing it as a mole-to-mole ratio, we're just going to change the units and make it a liter-to-liter ratio. So we can greatly simplify this problem by writing it out like this. 2.0 liters of chlorine, and now use our mole-to-mole ratio, but change the unit to liters. We produce 2 liters of HCl for every 1 liter of Cl2, just like that. So literally, the problem simplifies to 1 step. So it is now simply a 1-step problem. Volume to volume can just be a 1-step problem instead of a 3-step problem. It's just like the mole-to-mole conversions. So we just do 2.0 times 2, round to 2 significant figures. My answer is 4.0 liters of HCl. And that's it. Okay?